This is Refactoring Python. Please welcome Brett Slatkin. He's the author of Effective Python. Please give him a warm welcome.
All right. Start my timer. Whoa. Or else I'll lose track of time. All right. Hi, everybody. I'm Brett Slatkin. Thank you very much for coming to my talk. Today I'm going to talk about refactoring Python, why and how you should do it. The agenda here is we're going to go into the hows and whys. Then I'm going to go through some specific strategies that you can use to refactor your Python code. And then I have some follow-up, just things you should check out. If this was interesting to you, things that you should go after that to learn more. There's a bonus section here. I don't think I'm going to have time for it, but I really wanted to talk about that too. But I'm not going to get there. So you'll be able to get the slides if you can check it out later. So this is a novice talk. Some of this stuff gets harder and harder as the talk goes on. So if you are confused at all, you should come back and check out the slides, and I have a bunch of other detail. So I'm going to try to explain things very simply here. So the overall question is, what is refactoring? And it is restructuring, reorganizing, rewriting your code until it's obvious to a reader. And that obvious statement comes from a book called Clean Code by Uncle Bob or Robert Martin, you probably heard of. The obvious part of this is the most important thing, because you already do this. When you're writing code, you restructure things, you reorganize things, you rewrite things as you're going along. It's just part of what programming is. But the difference between programming and refactoring is really what you're optimizing for. So when you're writing code, you're optimizing for the fact that it works. And when you're refactoring, you're optimizing for the fact that you can read it and it's obvious. So that's the difference. Programming is about functionally having your code do what it's supposed to do. And refactoring is about making it obvious to a new reader so it's very simple and easy to understand. When you want to, what's the right time to refactor? When should you stop programming and start refactoring? When do you choose the right balance? Really good time to do it is if you know you're about to change the code to do something much more complicated than what it did before. So in advance of adding features, you should refactor. If you're trying to write some tests and it's hard to test code, that means that your code needs to be refactored. All code should be easy to test. If it's hard to test, it's not because the problem's hard, it's because your code isn't written the right way. So everything should be easy to test. If you find yourself copying and pasting code, or you have a bunch of functions that look the same way, that's a good time to refactor. Another one is brittleness. If every time you add one feature, you break the other 5 or whatever it is, then you should refactor. Things shouldn't be so closely coupled so that you're always breaking yourself. And then, just in general, when you're trying to read some code, you have some trouble, it seems too complicated, that's when you should refactor to make it easier to read so that a newcomer to your code base can really understand what you're talking about. So here's the why slide. This is not actually a graph based on data or reality, so this is totally anecdotal. But writing code and being a programmer consists, I think, of 3 main activities, which is writing and testing your code, refactoring your code, and then style, like pep8 and docstrings and that kind of stuff. So at the top here is my style usually, and anyone who's ever worked with me could probably agree with this. I just barely get the code to work, and then I'm done. Maybe I'll update the style a little bit. So anyway, don't do what I say, not what I do. The next step is kind of a good programmer. They spend a good amount of their time writing the code. Then they spend maybe the last bits refactoring it, reorganizing it, add really a lot of good style into it. But what I've noticed over time is that the great programmers, the people that you try to emulate and be like, wow, this code makes so much sense, it's so easy to understand, the reason is because they're spending almost half of their time refactoring. So at the point where I'm done, I've finished, it works functionally, the great programmer continues going on and refactors the code base so that it's easy to understand, so that the code's actually obvious. And they do this because it provides a better foundation for the future. It makes the code easier to test. Over the long run, it actually saves you time to invest in refactoring up front. Some people say that you shouldn't try to future-proof, and there's a bunch of kind of anti-patterns in that, but refactoring is really a good investment almost always. So that's why you should refactor. In terms of how, it's really a very simple idea. Again, you're already doing this as a programmer, but you look through your code base, you find things that could be better, you make them better. Of course, you already had tests, so you run the test to make sure that the code, you haven't broken it in some way. And if you have, you go through and you fix it up, you add more tests that cover cases you didn't have before, and you repeat that over and over again until you're satisfied that the code that's left is obvious. In practice, what this really means is just a few things. So you rename and split and move things around, parameters, methods. You split functions apart, you split classes apart, you split modules apart. So a lot of reorganization and editing. You simplify things. You take features away that you didn't need, or extensibility that wasn't necessary to accomplish the task. And then the hardest one is really you redraw boundaries. So if you have classes that relate to each other in some way, or modules that relate to each other in some way, you move the boundaries between those responsibilities. And that's the really difficult one to understand that I'm going to get into. So after you see this, you're saying, OK, well, I want to be a great programmer. I want to learn all about this. This is the canonical reference on how to do this. It contains a lot of kind of magical incantations that you can use in your code base to improve the quality of it. And it's great, and I really recommend reading it. But there's one very big problem, which is that it's really for Java programmers. And this is not a criticism of Java. It's just that it doesn't make any sense to a Python programmer. It's the way that you think about solving problems. It's a very single paradigm. It's all about classes. There's a more recent recent version of this book, another refactoring edition. Same concepts, but it's for Ruby programmers. So we're still left out here. We don't know what to do. So the goal of this talk is to talk about refactoring Python. So I wrote a book called Effective Python. It's not about refactoring in particular, but it's about the tools that you can use to write better Python. And my goal here is to provide some kind of Rosetta Stone to take the lessons from refactoring and apply them to Python so that you have some takeaways that you can use to refactor your Python code. So that's what we're trying to do. So I'm going to go through some specific strategies on refactoring Python. These are the three I think that matter. That book, Refactoring, has tons of other ones, but these are really the only three that I think you need to know. Everything else kind of follows from these three. Before you try to refactor your code, there's a few prerequisites. So you need to have tests. If you don't have tests, or you don't have time to write tests, I can't help you, and maybe you should just leave the talk. I don't know if it's the right place for you to be. You need to have quick tests. So every time you change your code for refactoring, you're going to have to run the tests again. So if your test suite takes 5 minutes or 10 minutes to run, you're going to have a bad time. The other thing is you need source control. You're going to make mistakes. And so every time you make a mistake, you need a way to back it out. And it might be a few days later that you realize you've made a horrible mistake and you need to go all the way back. So Git, whatever tool you want to use. And the last thing is you just need to be willing to make mistakes. I think that some people are unwilling to refactor because they're like, well, it already works. I don't want to break it. And you have to kind of get out of that mindset. All right, so let's go through the first example here, which is extract variable and extract function. These are the terms actually from the refactoring book that they use. OK, so we have some code here. So from here on out, you're just going to be reading a lot of code, so bear with me. I have a function that determines what you should be eating in which month. And so you pass a month into this. It checks to see if it ends with R or airy. If it is, that's a good time to eat oysters. That's an old rule of thumb. If the month is sometime in the summer, you should be eating tomatoes. And otherwise, it's probably asparagus. That's kind of my internal way of thinking about it. And if you actually test this code, it works properly. So November, you have oysters. July, you have tomatoes. March, you have asparagus. OK, so it works. The problem with this code is that a lot of these statements and the if statements get pretty complicated. There's a lot going on. It looks really simple at first, but what you can do is you take each of these kind of Boolean expressions and pull them up into variables at the top of the source. And when you do that, you see that there actually were all these hidden variables in the code below that expose how complicated this actually was. So this doesn't look that complicated, but when you pull all of the variables out to the top, you're like, wow, there's actually a lot of things going on in there. I didn't realize that. So that's just extracting a variable. You make it more clear at each level what test you're trying to do. And in Python, when you make any kind of expression, you're doing this anyway. There's really not a performance hit that you might expect, so there's no reason not to do this. Always prefer clarity if you can. But we can go a little bit further. So instead of extracting it into variables, we can extract them into functions. So we can say, OK, let's actually have one function that determines if the oysters are good, and one function that determines if tomatoes are good. And when we go back to the same code again, we have this complexity from before. And what we can do is we can replace each of these Boolean kind of statements with a call to the function. So now this is really easy to read. It's extremely obvious. If oysters are good, then you should eat oysters. If tomatoes are good, you should eat tomatoes. Otherwise, asparagus. But there's one kind of overarching problem with this, which is that if the function to actually determine if oysters are good to eat is slow for some reason, has to look things up in a database, something like that, then calling it in line in the if statement like this is actually going to maybe cause a performance problem. And so you can combine these two ideas of extracting a function and extracting a variable by pulling out these functions at the top and then saying, OK, well, time for oysters is this variable based on this function call, the return value from this function. Time for tomatoes is the same thing. Use them down below. So now we have the kind of the best of these two. We have the cached value, so we don't have to do computation multiple times, and we have clarity in the if statements at the bottom. Now, if you've ever written code like this, if statements always grow for some reason, and Boolean statements always grow as well. And so, these functions right now are really simple, but then suddenly someone needs to have oysters in Argentina, and then it's the southern hemisphere, and so then the months all change. And so this function is going to get more complicated and complicated over time. And so extracting a function is useful and it's helpful, but if you start adding more and more conditions in here, it's going to be really hard to understand what this is doing and how to test it. And when you get to that point, my recommendation is to extract a class from this. So this is the same idea, but instead of a function, it's a class. It takes a month, just like the other code did. But the big difference is that it saves the value in this result attribute. So it has self-r is if it does it in an r, array is if it does it in an array, and then the result is a pre-computed solution to the Boolean question. And it caches the result of the computation. And at the bottom here is this under bool method, which basically returns the outcome of that computation later. In Python 2, this is known as non-zero, which it might be more well known as. We can do the exact same thing for tomatoes. So we have this class that will cache this statement. And then when you want to use it, you take the functional version you had before, and you just switch it over to the class. So I'm just going to show you that one more time. That's all. It's like 6 characters that change. That's it. But the key thing here is that these if statements, because it's a class, and the class defines bool, Python will actually call the bool method as a special method on your class when it's being evaluated in an if statement. And so this makes it really easy to hide this complexity of this Boolean expression inside a class. And you might ask, why am I doing that? The function worked just fine. And the reason is for testing. So later on, you can go through here, create the class on its own, and then test all of the sub-conditions that actually caused oyster season to be the right time to eat oysters. So you extract a class to maximize the testability, and that's why you do this refactoring. So the things to remember is extract variables and functions to improve readability. If you're having trouble testing or you have complicated testing needs, use a class. And then bool, whenever you see under bool, it almost always means that it's a paper trail. It's trying to point at some decision that was already made. OK, going so far. All right, so that was extracting variables and extracting functions. I think I'm still doing OK on time. The next one we're going to talk about is extract class and move fields. OK, so this is another very important thing. You have pets, you need to keep track of them. So your pet has a name, and this is the beginning of your class. You have a pet, you name your pet. I have a pet. I don't actually have a pet, but I wish I had a pet named Gregory the Gila monster. This is a small poisonous reptile from the Southwest. So I create a pet named Gregory, print out the name, it works as expected. Another thing about a pet is you know when you got your pet. So you kind of know the pet's age is something you save on the pet class. This is not rocket science. You've probably all done something like this. Again, I can convince you that this code works. You create a pet called Gregory the Gila, age of 3, you can print out the pet's name and age. Now, another really important thing about having a pet is you got to give it treats. That's just the next step after you have a name for it. And so we want to keep a counter of how many treats we've given Gregory so we know, how he's doing. So I added a function for that that's going to keep track of the treats. Okay, this is not refactoring yet. We're not there. And again, I can prove to you that this code works as advertised. Now, over time, this class is going to get more and more things in it. If you have a pet, you need to keep track of its needs. And depending on what kind of pet it is, it has different needs. So I've added some other methods to this class. Does it have scales? Does it lay eggs? Does it drink milk? These are all things I need to know in order to take care of the pet. And I can add some additional helper methods in here to act on those attributes. So while I've added the attributes at the bottom here, has scales, lays eggs, drinks milk, I can add a property to this pet class to say, hey, does Gregory the Gila monster need a heat lamp? He's my pet. He's not living in the desert of the Southwest. He needs to stay warm. How do we do that? And so this is a little property that just says, OK, if it has scales and it lays eggs and it doesn't drink milk, it's probably a reptile. It probably needs a heat lamp. And again, I can show you that if I pass the correct parameters into the constructor of pet, this works as advertised. And Gregory the Gila monster definitely needs a heat lamp. Now, this is a trivial kind of made-up example, but this is already getting complicated. We have a bunch of fields in here. We have a bunch of concerns that are getting mixed together. And when you see this behavior where it becomes a class that kind of encompasses everything together, that's a great time to refactor. It's kind of a hint that it's time to refactor. And in the case of a pet, there's the petness of this class, the name, the treats I'm giving it, when I got it. And then there's the animal parts of it, like the fact that it has scales and it lays eggs. So in my mind, that's a really great boundary to refactor this on. And so let's talk about what refactoring a boundary is. Before when we were refactoring, we just went through, found code that was bad, kind of rewrote it, retested it, and we were done. When you're trying to change boundaries, like the relationships between classes, you got to do a lot more than that because the usage is more complicated. So you add a new interface, a better way of interacting with the class hierarchy. You maintain backwards compatibility with the code that was there before, so you don't break everything, so you can keep testing and making forward progress. You issue warnings for any old usage, and I'll get to what that means in a second. Then you spend as much time as you can migrating all of the old usage into the new usage so that you can get rid of the old code paths. And so once you do the migration, you run tests, you verify they're working, you improve those tests, and at the very end, you get to remove the code for the old interface. So you've refactored everything, you're done, you can get rid of the second path. So this is what I'm going to try to show you on that class. But before we go a little bit further, I just want to talk about warnings. So warnings are built into Python. It's a module. You can just import it. This is how you use it. You call warnings.warn. You give it a message. By default, it prints the message to standard error. If you're using various libraries, you probably see these already when you run the tests. There's a bunch of warnings printed to standard error. The reason that they're powerful is that you can run Python in a mode, and you can also do it by configuring the module itself, but you can run it in a mode so that all of these warnings become errors. And so that makes it really easy to say, OK, run this code, run the tests all pass, great. Run this code again, but this time, every time you hit a warning, raise an exception instead. And that lets you pinpoint all of the various places in your code that you actually that you're in the midst of refactoring that you need to move over to the new usage. So that's why you use warnings to do this. It's a tool to find the old ways so that you can replace them. So now I'm going to try to go through actually refactoring this thing. So I'm going to extract this animal class from pet. So this is pet before, this is animal after. It just pulls out the has scales, those other attributes. That's straightforward enough. It's a new class with the same attributes. The pet class before has a name and an age and then all these other attributes. I'm going to pull all those other attributes out, and then I'm going to have pet take an animal instance instead. So that's what I'm doing here. Now, you'll notice that the animal instance here starts off assigned to none. And the reason I'm doing that is to make it so it's an optional parameter. It's not necessary to pass it. If the caller doesn't pass it, then they might have used the old usage, which I'll demonstrate to you in a second. So here's what the body of this looks like. Now, this looks really intimidating, but it's really not that complicated. So let me just walk you through it. The top statement is saying, hey, if you passed both keyword arguments like has scales and you passed an animal instance, then you're doing something wrong. You used both the old style and the new style at the same time, and you shouldn't do that. It's either the old way or the new way, not both. So this raises a type error to specifically tell you to stop doing that and that it's not an allowed usage. On the next line, the next gray block there, if the animal is none, then that's saying, hey, you used it the old way, the old class. You didn't actually hand me an animal instance as a positional argument. So I'm going to issue a warning to you to say, hey, you should use animal instead of the old way. And then I'm going to construct an animal for you. So that's the backwards compatibility part of this. That's that third gray block. And then the rest of the constructor just goes as normal. It takes the animal, pulls it in. And so now you can see, I can verify that this works as advertised. I create an animal instance, and then on this line, I pass both an animal and has scales to the function, and it freaks out, and it raises an exception. You can't do this. You can't mix old and new at the same time. Similarly, if I just create a pet, this continues to work. I don't have an animal instance in here at all. It's not even mentioned. I just pass in has scales and lays eggs. And when you do that, you'll actually get a warning from Python, which is should use animal, so that you know that you're doing something wrong, and you should migrate your code. And then if you use it correctly, then there are no warnings at all. So you create an animal class, you hand the animal class to the pet class, everything works fine. So that's just the constructors part of this. The next part of this is the fields. So pet has these fields, has scales, lays eggs, drinks milk. We need to move those fields from pet into the animal. And what I mean by that is that anytime someone accesses pet, I want them to continue to work the way they did, but they should access the animal fields instead of the pet fields. So Python has this great property, helper decorator, that you can use. And what you can do is you can intercept a call to the old attribute, like has scales here, and you can essentially forward that request for that attribute into the inner class. So pet can say, hey, thank you for asking for has scales. I'm going to warn you that you shouldn't do that, but I'm still going to give you the answer you need by asking the internal animal class. And so that's what's happening here. And you can do that for all of the properties that you're trying to keep backwards compatibility with. And so, indeed, when we put this to the test, we can see that on this line with the gray, we're accessing the has scales. It works as advertised by, yes, Gregory the Gila has scales, but then it warns us that, hey, you should be using the animal attribute instead. If we use the correct usage here on animal, then we don't get a warning, but we get the same result. So you can see that's the only difference there, is that animal. And the last bit of this is the helper class, or the helper method. So the needs heat lamp. We want to move this over as well. This is about the pet needing a heat lamp. It's not about the animal needing a heat lamp because it has the sun in the desert. So we're not actually going to move this method. We're just going to forward the attribute access. So we just add animal to the inside of that, and then we consider this refactored. And so then when we access that helper, it's not going to warn. There's no reason for it to warn. The usage is still OK. We've just fixed the usage, so there's no problem. OK, so that's splitting a class. Things to remember here are to do that, use optional arguments. That's the best way to split a class. Use property to move methods and fields between the classes and the inner classes. And then you can issue warnings to let you know, hey, this is where my code is having issues with the old usage. This is what I actually have to migrate over to the new usage. So then I wanted to talk about some gotchas. If you actually try to apply this advice, you're going to get burned in a bunch of subtle ways that are unique to Python. And I want to go through those. So going back to the kind of refactored state, let's say that we've refactored everything, and this is what we're left with. We have this animal and the pet. And is this really obvious is the question. That's what you should always be asking yourself when you're refactoring. And I would say no, because an age of a pet is actually more of an intrinsic property of the animal when it was born, its existence. It has nothing to do with it being your pet. You could say when you adopted it, but that's not its age. Those are different things. So I'm going to try to refactor the age attribute into the animal class to move the field. So this is the general idea. I'm going to take age from down here, and I'm going to put it up there. So to do this, first I take the animal class, and I change its constructor. It's going to have the age property. It's optional because it defaults to none. Then I'm going to have this one if statement in there, which is going to issue a warning and say, hey, this is the old usage. You didn't pass the age to animal, so I'm going to warn you that you didn't do that. You should specify the age. And the rest of it's really straightforward. On the pet side, things are going to get more complicated. So now I have this age parameter there. I don't want the age parameter there anymore. So I want age to be backwards compatible only. So in order to do that, I'm going to change this parameter maybe age and maybe animal. And what this is saying is that you can pass 2 or 3 positional arguments to this method. And then I'm going to act on it depending on how many you passed me. So the first if case here is if maybe animal is not none. So that's saying if you pass me 3 parameters, then I'm assuming you gave me the old usage, where it was the name of the animal, the age of the animal, and the animal class itself. So if animal is not none, that means you have the old usage. I'm going to warn you. I'm going to save the animal instance, and then I'm going to assign the animal age myself for you for backwards compatibility. That's that second gray box. Otherwise, if you didn't pass animal, then animal is none. And then that means that the maybe age parameter, the second parameter, that just has to be the animal. So you called this with 2 parameters instead of 3. So I just assign it. Pretty straightforward. And similarly, from before, I used the property decorator to provide a forwarding of an internal field. I'll do the same thing here. I'll take age on pet, and I'll just forward that to the internal animal class instead. So this is backwards compatible. I'll warn about it. So if anyone's using it, I'll let them know. So they have to migrate their usage. And so now we can test this out. We can create an animal class in the old style, where the animal has these attributes, but the age is still on pet. This will issue a ton of warnings. So on the animal class, it issues a warning because you didn't pass age. On the pet class, it issues a warning because you did pass age. And then when you actually print out the age at the bottom here, that also issues a warning because you're accessing the attribute in the wrong place. But it still works. So you can migrate your code one piece at a time. The new usage, on the other hand, doesn't issue any warnings at all. So you pass the age into animal. You access the age property on the animal when you print it out. You don't pass any age into the pet constructor, no problem. Now, one thing, if you've had pets, what happens is it always, like, someone's pet is much older than they thought. This happens a lot of the time. And so you're going to need to reassign the pet's age. This is going to happen at some point. So you go in and you say, OK, I have this pet. I'm going to reassign his age to 5. And you'd be surprised that when you try to do this, you get an error of can't set attribute. And the reason is that you handled the read case of the age attribute, but you didn't handle the write case, the set or the get. And so you actually need to use properties extra bit here called setter. It's built, again, this is built into Python, built into the property decorator. And you would add another compatibility property for set. And that would take the new age that the pet has, and it would forward that assignment down into the inner class of the animal. It would also issue a warning. And so now this code would work as advertised, as you'd expect, based on the old style, but it would issue a warning when you do that, so you know you need to migrate it. And then if you do it the right way, then you don't get a warning. So finally, you have this animal class, age is in the right place. You have a pet class, has no concept of age. Everything's going great. Again, Gregory's older than you thought. You're trying to reassign this. And let's say that you interact with pet classes all the time, so you're writing some code to assign the age to 5. And the question is, what's going to happen here? What do you expect to happen here? And it's doubly broken. So if in your mind you have muscle memory of how to use the pet class, and you assign to age, you've done this refactoring, you move the age property from pet into animal, when you do this assignment, Python, for better or worse, will just assign any property to any class just because you said so. And so you can hide errors in here where you didn't even realize that you're using the old usage. And so you assign the age to 5, but it stays as 3 because those are actually different properties. One is on the animal and one is on the pet. And that's one of these big gotchas you'll get in Python refactoring, especially around assignable attributes. And the only real way to defend against this, so yeah, no error. That's what I'm trying to say here. So the only real way to defend against this is to leave tombstones around. And these are attributes. The only goal of these properties is to raise exceptions when you do something wrong. So if you have code that's been used a certain way for a very long period of time, and now you're migrating it over to some new style, you should leave these around for a while because they'll catch really simple errors. And they'll raise exceptions anytime someone does it the wrong way. And wow, thank you for the managed. Let's see, I was worried that might happen. All right, cool. Great. OK, so yeah, so that's all I'm saying. You have these tombstone properties. And so then if you actually try to access the pet age here, it'll throw an error immediately. And that's just a defensive thing. So this is because of old habits dying hard. This will protect against it. OK, so things to remember. Use property setter if you're trying to move assignable fields. Use tombstone properties if you're trying to, if you want to prevent yourself from hurting yourself with those refactorings. And that's the main stuff. For follow-up, there's 3, I think, good sources of information you should check out. One is Doug Hellman has this Python module of the week. It's been ported to Python 3 now. It's great. There's tons of things in there. One is on warnings. So if you want to understand all of the different ways you can use warnings, check that out. There's a great talk by Jack Diedrich about stop using classes, which is kind of the opposite of this talk. I'm telling you to use classes. He's telling you not to. I think somewhere between the two is really good. And that's a really good Python style and refactoring kind of talk. And then Raymond Hedinger last year had this Beyond PEP 8 talk, which is all about, I think, the structure of code and the relationships that classes should have. So that's worth checking out. If you want this talk's code and slides, it's on my GitHub on PyCon 2016. Again, I had this book that I wrote on effectivepython.com. There's also a deal of the day during PyCon that you can actually get an e-book version of this at a discount, which is right there. And then if you'd like to talk to me more, this is where you can find me online. And I'm totally out of time, so if you have any questions, I'm just going to be standing. I'll be here, and then I'll be right outside, and I'm wearing red, so come and talk to me. And that's it.